Hello. 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 Hello, my dear friends. Hello. Anyone is in live? Hello. 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 Anyone is in live? Hi. Hi, Murli. Hi. Hi, Ra. Hi. 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 Right. Hi, Rishika. Hi. 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 Done. Now, is the voice and the video is clear? The voice and the video is clear? Murli, Rishika, any other? The voice and the video is clear? Audio and the video is clear? Yes, sir. Yes, sir. Good, 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 good. Right, right, right. Now, now, clear, sir. Good. Now, listen. Already we have shared the. Already I was shared the notes in the group with the same reference only. I was going to teach. Okay. Just follow the lecture. Okay. No need of writing the notes. If you want to write the notes, you can write. But if you need any points, so listen to the class carefully. Now wherever the questions I was asking, try to give that answers to that question, and wherever if you are not able to understand anything, you can ask me over there. Okay, clear kada? Done. Malla, see, whatever we have studied in the which one, GOC and the hydrocarbons, again that basics again it will repeat. So listen to the class carefully. Wherever you are getting difficulty, there you stop and ask me, or you can text me in that which in the chat box. I will start. Okay, now chal. Now we'll start the lecture. Now here this haloalkenes, haloarenes are very important, because here we are having the very important reactions in this haloalkenes and the haloarenes. Clear? Now we'll start the haloalkenes, haloarenes. Before going that, wait, I will just minimize my video so that it will be good for us. Okay, done. Right. Now, right. Here, now in the haloalkenes and the haloarenes, what is the main thing we are going to see? Here also first things, the haloalkenes and the haloarenes chapters want to be more clear. First of all, you should not have any confusion in between what is the base and what is the nucleophile. Where we have to identify the base and where we have to identify. See, sometimes base itself will act as a nucleophile. Clear? Base itself, it will be sometimes nucleophile itself will act as a base. Clear? Here in some case OH, if you take, in some case OH is acting as a base, in some case OH is acting as a nucleophile. If that if that one misconception, if it is clear for you, then in the haloalkanes, haloarenes, now SN1, SN2, clear, in that reactions you will not have any difficulties, you will not face. Clear? From the starting onwards, from the basic onwards, I will explain very clearly. Now listen, here first of all you should know, in the organic reaction generally how it will be happened. It will be happened with the substrate, or it will go with the which one, reactant. It will go with the reactant plus reagent, and with the help of solvent, it gives the product, right? With the help of the solvent it gives the product. This we know. Now in this, before going to start our lecture, I just want to make you to clear what is the base and what is the nucleophile, and which one will be act as a polar protic solvent, which one will be act as a polar aprotic solvent. Now which one will be act as a base and which one will be act as a nucleophile, I will clear. First of all we will clear what are the solvents that we are going to see in this reaction. What are the solvents that we are going to see, and what is the role of that solvents will do in the haloalkane. Solvents will also play very crucial role in the which one, in the haloalkanes and the haloarenes chapter. Clear? Now in the solvents we are having the two types, right? One is a non-polar, one is a polar. In this polar again we are having the two, one is protic, one is a aprotic, one is a protic and one is a aprotic. Now what is the meaning of the non-polar and what is the meaning of the polar? Polar means dipole moment it is having. Clear? Non-polar, what are the some non-polar solvents? Example, can anyone say what are the non-polar solvents mainly we are going to use? What are the non-polar solvents that mainly we are going to use? What are the some non-polar solvents that mainly we are going to use? Can anyone? What are the mainly that non-polar solvents we are going to use? Non-polar solvents. Fastly, Amma. Whenever I was asking the question, try to give the answer if you know. If you don't know, try to give the question mark, so that when I was asked the question, I will wait for your answer. So in that time what it will happen, the time lagging will be happens. That's the reason what to do. If you know the answer, give me. If not, give the question mark, so that I will explain, so that there will be the what, time lagging undadu. Any non-polar solvents example? Hello Pranit, hello. What are the examples for the non-polar solvents? Okay. Just now itself the class has started. Don't worry. Now can anyone? What are the non-polar solvents that we are having? What are the non-polar solvents that we are having? What are the non-polar solvents that we are having? Example of the non-polar solvents? Benzene, okay, benzene. Then after n-hexane. Then after CCl4. Clear? CCl4, n-hexane. Then after that petrol, hexane, n-hexane, petrol, kerosene, and the etc. These are the some non-polar solvents we are going to use. Now here mainly we are going to see the what, polar solvents. These two terms we will going to use repeatedly in the haloalkanes and the haloarenes. Polar protic solvents and the polar aprotic solvents. So before going that one, in the classification of the solvents, first we will go with the what one? What is a polar protic? What is the meaning of polar protic? Or what is the meaning of the protic and what is the meaning of the aprotic? Clear? Now protic solvent and the aprotic solvent, in that what is the definition of the protic means? What is the meaning of the protic, Nana? Can anyone? What is the meaning of the protic? No. solvent which can acts as H plus donor. H plus donor. H plus donor is a protic. Any solvent which can act as a which one? H plus donor. Aprotic means H plus donor absent. If any H plus donor is absent, that we call it as a aprotic. Done? Clear? Now the polar and the non-polar, you know. Polar and the non-polar. If the dielectric constant, if it is present, that is polar. If the dielectric constant, if it is absent, that is non-polar. Done? Now we'll see the classification of the solvents on the basis of which one? This is a solvent. This is a solvent. Now which one is a polar? This is a polar. And another one is a non-polar. Done. Next one, protic. Next one is a aprotic. Done. Clear? Now I will ask you this. When I was written the solvent here, then you have to say me in which category it will come, whether it will comes under the polar protic or polar aprotic, or non-polar protic or non-polar aprotic. Okay, very fastly you have to give the answer. If you know, say me the answer. If not, give me the question mark, so that we will save our time, because more content we have to cover here, and with the including questions. SN1, SN2, SNI, SNNGP. So 4 very important reactions we have to cover with the n number of questions. So don't lag, and if you are having any doubt, you can ask me, and if you know, say the answer. If not, give the question mark. First one, space prints. Hi. Now space prints, what is on the basis of question? Okay, fine. Now listen. Now H2O solvent will comes under which category? H2O will comes under which category? H2O will comes under which category? Polar protic or polar aprotic? Polar protic means PP. Don't write total polar protic. If the polar protic means PP, polar aprotic means PAP. Okay? Polar protic PP. If it is polar protic, PP. Polar aprotic, PAP. Okay, polar protic. This is polar and protic. Done. Clear. Fine. Now comes to the next, HF. HF will comes under HF. HF. PP. Good. Next, D2O. Next, D2O. Next is a D2O. Next is a D2O. D2O. No. D2O and the H2O is same. Don't get confused. This is deuterium. This is H2O. This will also polar protic only. It will also comes under the polar protic only. It is not a polar aprotic. D2O also polar protic only. Don't get confused. Then ethyl alcohol. Okay. Hydrogen isotope only, right? Ethyl alcohol. Ethyl alcohol will comes under which category? Ethyl alcohol will comes under which category? Ethyl alcohol. Ethyl alcohol will comes under which category? PP. Good. liquid ammonia, liquid ammonia, liquid ammonia, liquid ammonia, liquid ammonia PP. Okay, next acetone, next one acetone, 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 polar aprotic, good, polar aprotic, this is polar aprotic, this is not the polar protic, this is polar only, but it will comes under the aprotic solvent. Done. Next, formic acid, next one is the formic acid, next one is the formic acid, next one is the formic acid. Namaste Captain America, namaste, good evening, good evening. Now formic acid, formic acid will comes under, formic acid will comes under polar protic, polar protic, good. Now next one, next one is a ether, 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 next one is a ether, next one is a benzene, next one is a n-hexane, next one is a n-hexane, next one is a tetrahydrofuran, non-polar aprotic, good, non-polar, non-polar aprotica, non-polar, that is ether is non-polar aprotic. Then next, benzene is non-polar aprotic. Amma, who are in the online, others, they can also show us, good evening, good evening, others, they can also try to say me the answer. Only the one is responding. Others try to say me the answers. Okay? Only one is saying the answers. Try to say me, Amma, whether it is correct or wrong, we can rectify it, right? Next one, tetrahydrofuran. Next one is a tetrahydrofuran. Next one is a cyclohexane. Next one is a cyclohexane. N-hexane, non-polar aprotic. Tetrahydrofuran, cyclohexane. Tetrahydrofuran, cyclohexane. Tetrahydrofuran, cyclohexane. Which category it will comes? Tetrahydrofuran, cyclohexane. THF, non-polar aprotic. Non-polar aprotic, good. Okay. Next, good, Murli, good. Next other, cyclohexane, non-polar aprotic, good. Non-polar aprotic, done. Now, see if these solvents are clear. Now, whatever may be the solvent they may ask, you will not get any confusion which solvent will be act as a which category. Next to DMSO. Next to DMSO. Next to DMSO. Next to DMSO. Eprotica. DMSO. Now DMSO structure will be dimethyl sulfoxide. Now this is a DMSO. DMSO will comes under DMSO non-polar eprotica. DMSO non-polar eprotica. DMSO will comes under which category, Nana? DMSO. This is partial positive charge and this is partial negative charge, right? This is polar. But here there is no any chance of donating. There is no any chance of donating the which one? Hydrogen, right? So it will comes under the which category? It will comes under the polar eprotic. So DMSO is a polar eprotic. No, this is polar eprotic. DMSO is a polar eprotic. These solvents will play very crucial role in the SN2 reactions. So try to remember. Next, DMS, dimethyl formamide. This is dimethyl formamide. Now dimethyl formamide, this is the structure of dimethyl formamide. Now this will comes under which category? This will comes under which category? Polar protic or polar eprotic? Polar protic or polar eprotic? Dimethyl formamide. Polar protic or polar eprotic? Polar eprotic. Good. Polar eprotic. Good. Polar eprotic. Right. Next one we are having the DMA. Next one is a DMA, dimethyl acetamide. This is dimethyl acetamide. Now this will comes under which category? Dimethyl acetamide. That is polar eprotic. Dimethyl acetamide will comes under the polar eprotic. Next HMPA, hexamethylene phosphoramide. Now the structure will be hexamethylene phosphoramide. This will comes under hexamethylene phosphoramide. It will comes under polar eprotic. It will comes under the polar eprotic. Remember, this is also one important polar eprotic solvent. This will also one very good polar eprotic solvent. I hope almost very important solvents I explained very clearly. Done. Now next we are going to see almost what are the solvents that we are going to see, that already I explained. Next the very basic that we are going to use, and what are the basic that we are going to use in our substitution reactions, that is first base. Okay, now base and the nucleophile. First, what is the meaning of the base? Electron density donated to the hydrogen or proton is base. Done. Clear? Now if any base, if it is there, done. If the this is one CH2 and this is a Cl, and here it is having the H. If it is subtracted this one, now this bond pair of electron will be shifted toward this chlorine. Now this one we will call it as a base. Then when we call it as a nucleophile, now electron density donated other than other than H plus. Electron density donated other than H plus, we call it as a nucleophile. Clear? Now here the CH2, and if it is a H, now if it is attacked here and the Cl is leave, done. Now here this we call it as a, this one we call it as a which one? Nucleophile. If you are getting this B minus means you take it as a nucleophile. Okay, done. Now this one we call it as a nucleophile. Done. Here the many of the students, they will get mistake and they will do the mistake how to identify the nucleophile, where to, which is the nucleophile, when it will act as a nucleophile, when it will act as a base. Now in the polar protic solvent what is the role, in the polar aprotic solvent what is the role. Now where to identify. Clear? Now the factors affecting the which one, the factors affecting the nucleophilicity. Remember, these are very important. Now this is very easy to remember and in the same way easy to confuse also. Based on the question what they are asking, we have to do. See here the factors affecting nucleophilicity. See, whenever I asked the questions, try to say me the answer. Okay, now factors affecting the nucleophilicity. Now what are the factors affecting in the nucleophilicity? First, nucleophilicity is directly proportional to the electron donating groups, done, and inversely proportional to the electron withdrawing groups. This is a one key point you have to remember. Clear? This is a one key point you have to remember. Done. Here next here is a where it will be act as a nucleophile and the base. Sometimes what it will happen. Now first one, case 1. In this case 1, here when it will act as a base and when it will act as a nucleophile. Sometimes they will ask you which among the following is nucleophile and which among the following is base. So in the case 1, first one, here the nucleophilicity and basicity order is same. In the case 1, in which one basicity and the nucleophilicity order is same. When it will be happened, you know, when it will happen, if the nucleophilicity site is same, if the nucleophilicity site is same, then the nucleophilicity order and the basicity order will become same. Nucleophilicity order and the basicity order will become same. Now one thing you have to remember, Nana, whenever they are asking the which one is a strong nucleophile or the strong base, if they ask strong nucleophile or the strong base, if they ask strong acids conjugate base, strong acids conjugate basis is a weak base. Blindly below, strong acids conjugate base is a weak base. So weak bases are which one? Poor nucleophile. Because if in this case when they are having the same nucleophilicity site, whatever the order they have given, in that order you have to cross check which one is the weak acids conjugate base. Weak acids conjugate base, and that weak acids conjugate base is a what? Strong base as well as a strong nucleophile when they are having the same donating species. Now listen. Here if suppose if they have given in this manner SO3 CF3, this is 1. Now next one MESO3 minus, this is 2. Done. Next one acetate ion COO minus, this is 3. Next 4 PHO minus, this is 4. Next is a OH minus, this is 5. Now next one is a ETO minus, this is a 6. Now you say me nucleophilicity order in this among the 1 to 6, which one will be act as a strong nucleophile? If this basicity order and the nucleophilicity order, if it is clear for you, now in the SN1, SN2, E1, E2, E1, CB, you will not get any mistake and you will not do any mistake. Which one is the nucleophilicity order? I am asking nucleophilicity order. All of them having the same nucleophilic center. See, O minus, O minus, O minus, O minus, O minus, O minus. Order fastly. If you know, say me the answer. If not, give the question mark. I will explain. If you know the order, try to say me. If not, give the question mark. If you know, try to say me. If not, give the question mark. I will explain. Which is the strong nucleophilicity order? Rest any others? Rest any other? They are trying. Which among the following are the strong nucleophile? What is the strong nucleophilic center order? Anyone trying? Okay. No. Here the order will be what? 1 minute. Order will be 6 greater than, 5 greater than, 4 greater than, 3 greater than, 2 greater than 1. Can anyone say the reason? Can anyone say reason? Can anyone say? You wait. Don't say. Pranit, you don't say the answer. Okay? Let others try. Okay? Done. Now write. Why? Because you can see, we know strong acids conjugate bases they are stabilizing, right? Here you can see this negative charge of this here. If you take this one, what is the meaning of the nucleophile? Nucleophile means it should be donate very fastly to the any electron deficient or any other species. Then if this negative charge is stabilizing by the what? Strong, which one? This is a strong minus H group as well as a strong minus I group. Sixth is the weak base. Weak bases are the which one? Good? No. Basic strength order as well as a nucleophilicity order is same. For this one, both the order is same. Basicity and nucleophilicity order, both are same. So you have to be very careful. What is the one key point you have to remember? Key point you have to remember. If nucleophilicity site, if the nucleophilicity site is same, basic and nucleophilicity order also same. Nucleophilicity and the basicity and the nucleophilicity order is same. This is the one key point you have to remember. Done? Is it clear? If the which one? If the nucleophilicity site is same, basic and the nucleophilicity order will become same. Done? Next one. Second case. Now, next to case 2. In this case 2, in which case? Here the nucleophilicity order. Yes, Nana, Captain America. Any doubt? Here the nucleophilicity and basicity here the nucleophilicity and the basicity order is different. Now here the case 2 where the nucleophilicity and basicity order will be different. Now how the nucleophilicity order and the basicity order will be different, in which case? Here you see, if suppose I minus or no nucleophilicity order and basicity order, nucleophilicity order and the basicity order, nucleophilicity order for the I minus, Br minus, Cl minus and F minus, and basicity order for the I minus, Br minus, Cl minus and the F minus. Can anyone say what is the nucleophilicity order and what is the basicity order for this one? Here the what? Nucleophilicity site is different. Here the nucleophilicity site is different. Here the nucleophilicity site is different. Can anyone say the answer? What is the nucleophilicity order and what is the basicity order? Okay, I will give you the numbering 1, 2, 3, 4 so that it will become easy. 1, 2, 3 and 4. If you know, try to say me the answer. If not, give me the question mark. I will explain. If you know the answer, try to say me the answer. If not, give me the question mark. I will explain. See, if the case 1, case 2 and the case 3, if it is clear for you, in the SN1, SN2, E1, E2, E1, CB, in all the reactions, you will never and ever you will get the phase, you will never and ever you will get the problem. Which one will be the base and which one will be the nucleophile, where to act as a nucleophile, where to act as a base. Now, 4, 3, 2, 1 and 1, 2, 3, 4. 4, 3, 2, 1 of which one? 1, 2, 3 of which one? Murli? 4, 3, 2, 1 of which one? And 1, 2, 3, 4 of which one? Basicity is 4, 3, 2, 1. Good. Basicity is 4, 3, 2, 1. And the nucleophilicity is 1, 2, 3, 4. Yes. Good. Good. Here we know strong acids conjugate bases are what? Those are, in this case, here the strong acid, as we know, fluorine, when we move from the top to bottom, for the here the nucleophilicity will be high for the more, because that is a which one? Acidic strength order, and the strong acids conjugate base is a which one? Good leaving group. Here in this case, I minus, Br minus, Cl minus and the F minus. I minus is a which one? Strong nucleophile. But here the basic strength order will be reverse. In this case, when key point, this is a key point you have to remember. Key point. In the given species, if different nucleophilicity, is it clear? The different nucleophilicity site of same group elements, the nucleophilicity site is different and those are belong to the same groups, then nucleophilicity order and basicity order is different. Clear? This point is to be clear for you. Done. Next one. Can you say me next? Can anyone say me the answer? Including Pranit, if you are in the live also, you can say me the answer. if suppose NH3 if they have given, and phosphine PH3 if they have given, ASH3 if they have given, SbH3 if they have given, and BiH3 if they have given. Now what is the nucleophilicity order for this one, and what is the basicity order? What is the basicity order for this one? 1, 2, 3, 4, 5. Any other they can try. What is the basic strength order and what is the nucleophilicity order? Can anyone say me the order for the nucleophilicity order and the basic strength order? Nucleophilicity order. 5 is highest. Clear now? Just now I explained. If any species, if they have given in this manner of same group, if they have given of the same species, if they have given, then what I explained very clearly. Down the group, what it will happen? Nucleophilicity will be increases. Why? Because nitrogen being the smaller size, this nitrogen lone pair of electron will be very nearer to the which one? Nucleus. Due to that, its polarizability are here, it will be more polarized or polarizable. These electrons will be strongly attracted towards the nucleus. But when it comes to the bismuth being the high size, its electron density will be given very easily when all are from the same group. So which one? 5 greater than, 4 greater than, 3 greater than, 2 greater than 1. Now basic strength order will be reverse, right? Then 1 greater than, 2 greater than, 3 greater than, 4 greater than 5. Is it clear? Done. Next. Last case. Case 3. If it is clear, then all the misconceptions between the which is a nucleophile and which is a base will be clear for you. Done. Here, where the nucleophilicity and basicity is same, nucleophilicity and the basicity is same. Clear? But when nucleophilicity site is different, if the nucleophilicity site is different, then nucleophilicity and basicity order will become same. When all belongs to same period. If they are belongs to the same period, then their nucleophilicity site and basicity site will become same. Which one? If suppose F minus they have given and NH2 they have given, NH2 minus they have given, okay, then OH minus they have given, CH3 minus they have given. Done. Among the 1, 2, 3, 4, what is the nucleophilicity site order and the basic strength order? Nucleophilicity site order and the basicity order will be same. Nucleophilicity site order and the basicity order will be same for the when nucleophilicity and the basicity is same, when the nucleophilicity site is different, but all should be belong to the same period, because fluorine, nitrogen, oxygen and the carbon all belongs to the same which one? Same period, right? So nucleophilicity order will be 4 greater than, 3 greater than, 2 greater than 1. Why? More electronegative atom bearing the negative charge is more efficient in this case. More electronegative 4 3 2 1 4 no not 4 3 2 1, sorry, not 4 3 2 1, actually 4 2 3 1. NH2 minus OH minus. NH2 minus is having the higher nucleophilicity site than the OH minus. So the order will be 4 2 3 1. Order will be the 4 2 3 1. Is it clear? That you have to cross check. 4231. Next one, the next concept that we are going to see, the which one last, yes, next, the next basic I will explain and I will stop, because these basics are clear. Now based on that you have to be very careful. Now I will ask the questions, some questions I will ask you, then I will stop this nucleophilicity and the basicity. Now next we will go to the leaving group. That leaving group, nucleophilicity, basicity, if it is clear. Now in our SN1, SN2, SNI and that reactions, we will not get any mistake, or we will not do any misconception over there. I will ask you which one is having the higher nucleophilicity site, you have to say me. First one, among the OH minus and H2O, which is having the higher nucleophilicity. Now in the second, among the NH2 minus and NH3 minus, nucleophile is higher in. Nucleophile is higher in the first one. Next, third one, RO minus and ROH. Next, fourth one, RS minus and RSH. Say me, can anyone? In which case the nucleophilicity or nucleophile is higher? In which case the nucleophile is higher? OH minus. Good. In this case OH minus. Second one. The second one, NH2 minus. No, NH2 minus. Here the negative charge, any species if it is bearing the negative charge, it is having the high nucleophile than the neutral. Believe? No. Any species holding negative charge will have high nucleophilicity site. Okay, same order for all, okay. Done. Now you have to say me, in this case which is having the higher nucleophilicity, you have to say me in this case. Okay, done. If suppose H2O and H2S, in the second case ROH, RSH, okay. Then in the third case, now OH minus and SH minus. Now you say me, in this case which is having the higher nucleophilicity? In which is having the higher nucleophilicity? H2S. Yes, good. What I said. Now if both belong to same group, down the group, nucleophilicity site increases. Done. Now here the RSH, because here the ROH and the SH both will belong to the same group. Then in the third one, third one is this one. Next one, here you have to be very careful. Now in this case you have to be very careful. If suppose this is one very important species, you have to be very careful with this one. If suppose butoxide they have given, tertiary butoxide if they are given and ethoxide if they are given. Among the 1 and 2, which is having the higher nucleophilicity site? Among the 1 and 2, which is having the higher nucleophilicity site? It will make you somewhat confusion. Now you have to say me. Which one is a strong nucleophile? Which one is a strong nucleophile? One nucleophilicity order. Nucleophilicity site or nucleophilicity order. No. Here nucleophilicity order will be the ethoxide is having the higher than the tertiary butoxide. Which one? Ethoxide is having the which one than the tertiary butoxide, because tertiary butoxide due to the steric crowd, see, nucleophile means it should be attacked to the other than proton or other than nitrogen. Please see, proton is very minute. This steric crowd will not affect the anything when they are catching the proton. So that's the reason for this one. One is having higher, one is having higher in the basic strength. In the basicity order, 1 is greater than 2. But in the nucleophilicity strength, 1 is less than 2 in the nucleophilicity strength. Why? Because due to the steric crowd, its nucleophilicity site will get repulsion. See, nucleophilicity site decreases. Then, is it clear? Due to the more steric crowd, its nucleophilicity site will be decreases. See, in this case you see, Nana, if suppose here this one carbon it is there, let's suppose here the 1H, here the 1H, and here it is a H, and here it is a which one? CH3, let us assume here it is a Cl. If suppose this O minus as the nucleophile, if it is want to go and attack here, then what it will happen? Here it will be get repulsion, right? Due to this total steric crowd, it will get repel. Here the hydrogens are there, here the methyls are there. What it will happen? Due to that, it will get repel. Due to that repulsion, its nucleophilicity site will be decreased. But when it is acting as a base, it will act as a very strong base, or it will act as a strong base. Why? Because here the proton is a very minute. This proton, what it will happen? It will readily abstract this one. Then if electron pair donor, if the electron pair is given to the hydrogen, it will act as a base. Other than hydrogen, it will act as a nucleophile, that we know. So that's the reason here, due to the steric crowd, its nucleophilicity site will be decreases. Only the basic strength will be increases in the tertiary butoxide and the ethoxide. You have to be very careful with this one. Clear? They will make you confused with this one. Is it clear? Next concept is leaving group. The concept is the next concept is which one? Leaving group. This is very important, and with this one we will stop. We will stop the basic and we will go with the directly to the reactions. Okay. Now, in these leaving groups, first key point you have to remember: weak bases are good leaving groups. Weak bases are good leaving groups. Done. Weak bases are the good leaving groups. Then what are the examples for the weak bases and which one will be the good leaving groups? Now, leaving groups should leave from substrate as stable compound or ion, Clear? or molecule or gas, etc. Clear? This is the definition of the leaving group. Leaving groups are the weak bases are the good leaving group. Strong acids conjugate bases are the weak bases. Now listen, here I will ask you one questions. Now that you have to say me the answer. You have to say me the answer. If suppose ROH they have given. ROH they have given. Clear? Is this ROH? This OH is a good leaving group or bad leaving group? This OH is a good leaving group or bad leaving group? This OH is good leaving group or bad leaving group? If anyone in the live, try to say me the answer. This OH is good leaving group or bad leaving group? Now, here, this OH, if it is leave from the substrate, no, OH is not good leaving group. This is strong base. This is strong base. Strong bases are bad leaving group. This OH is a which one? Strong base. After leaving from the substrate, it will become the strong base. Strong bases are the bad leaving group. But these bad leaving groups making good leaving groups, making into good leaving groups. How we have to make the bad leaving groups into the good leaving groups? By reacting with the H plus. When it has abstracted this H plus, then it will convert it into the oxonium ion. This is a oxonium ion. Clear? Now oxonium ion, by taking this bond pair of electrons as the H2O, it will be eliminated. H2O is a weak base. And which one? Bad leaving group we have converted into the good leaving. Weak bases are the good leaving group. Is it clear? This is very, very important. So among the OH and H2O, if they ask which is a good leaving group order, if they ask among the 1 and 2, which is a good leaving group? Which is good leaving group? OH and the H2O. H2O is a good leaving group. Clear? Now here these are the some basics, some basic good leaving groups. What? I minus is a good leaving group. Next, Br minus is a good leaving group. Cl minus is a, these are some good leaving groups order. Good leaving groups. Clear? Then N2 is also a good leaving group. And very important leaving groups you have to, some other good leaving groups also there, that you have to remember. What are that? This only they will give you and they will make you somewhat confusion. If suppose good leaving groups, this we are going to use in our entire, which one? In our entire substitution reactions, good leaving groups. These are the some examples for the good leaving groups. First one, this one we call it as a nosylate. This nosylate is a good leaving group. Then after that we are having the nosylate. After that we are having the brosylate. This one is a brosylate. Brosylate is also a one good leaving group. Then after that we are having the normal. Here next we are having the normal basylate. Next one we are having the tosylate. Clear? Now this one we call it as a tosylate. Clear? Now this is a good leaving group order. This good leaving groups also will play very important role. Clear? This is also you have to remember. Sometimes they will give you the OTS. OTS in this manner also they will give. OTS also a good leaving group. Clear? Now here these are the some examples that we have studied for the which one? Basics to understand the haloalkenes, haloarenes. Now we'll start the chapter haloalkanes. Now listen, here the SN1, SN2, SNI, SNNGP I will try to finish today. Now listen carefully. What are the haloalkanes and haloarenes? First we'll go with the haloalkanes only, and the haloarenes we'll study later. Now here the one, what is the meaning of the haloalkanes? Now for the hydrocarbon, for this hydrocarbon, if any halogen is replaced, this halogen is replaced and hydrogen is replaced and halogen is added, this we call it as a haloalkanes. Done? Clear? Now here we are having the halogens like F, Cl, Br, I. And if it is haloarenes, for the benzene halogens are added. For the benzene, if the halogens are added, that we call it as a haloarenes. Done? Now haloalkanes. In the haloalkanes we are having the two types. One is saturated, this is CH3Cl, this is saturated. Clear? Now unsaturated, now this is a allyl chloride, we call it as a which one? Unsaturated. Done? This is a saturated and another one is a unsaturated. Now first one, what are the different types of the reactions that we are going to see in the halogens? Okay, different type of the reactions that we are going to see, different types of reactions in halogen derivatives. Anyone is in the live? Anyone is in the live? Once if you are in the live, just say me hi, because here we are going to start the very important reactions. First one is a SN type. Yes, Pranit, okay. First one we are going to see the SN type reactions. Second type we are going to see the elimination reactions. Okay, fine. Next one we are going to see the SNI type, and the fourth important reaction that we are going to the ARSN, so aromatic substitution nucleophilic. Then in this lecture we are going to cover SN type and the SNI, SN type and the SNI. Then in this first one, based on molecularity of SN type. SN type reactions are two types. First one is a SN1, clear, and the second one is a SN2, SN1. Now here in this SN1, polar protic solvent is used, polar protic solvent. In this SN2, polar aprotic solvent. In this polar protic solvent, in this one polar aprotic solvent. Done. Here before going to start the SN1, I want to give you the what are the role of the solvent will do in the reaction. What is the role of solvent? Clear? Now what is the role of the solvent will do with the halogens? Now we'll see. First I was taking the one polar protic solvent. Polar protic solvent. Can anyone say me the one example of polar protic solvent? Polar protic solvent. Can anyone say the polar protic solvent? Example, polar protic solvent example. H2O. Now, in the polar protic solvent, in this polar protic solvent, if I was added in this polar protic, let's suppose I was taking this is H2O. This is H2O, polar protic solvent. In this polar protic solvent, if I was added the NaCl, what it will happen now we'll see. Now this NaCl will be dissociated in this manner. Now this polar protic solvent, in this polar protic solvent, oxygen it is having the partial negative charge. Due to this partial negative charge, it will form the bonding. All the H2O molecules will be surrounded to it. Clear? All the H2O molecules will be surrounded to it. Now all the H2O molecule has been surrounded to it means what it will happen? Now Na plus is also cation, right? So cation is soluble. Cation is soluble in polar protic solvent. Then when it comes to the anion, Cl minus, here the H. Now due to the partial positive charge, it will form the bond. Here the H. Due to the partial positive, it will form the bond. Now it will form the bond. It will form the bond. Done. Now what it will happen? All the H2O molecules will be surrounded with this Cl minus. Then what it will happen? Anion also will be soluble. Anion is also soluble. So if the polar protic solvent, if they have given, the first thing you have to get it in your mind, what? Both the cations and the, so in the polar protic solvent, both cation and anion is soluble. Done? Clear. Next, when it comes to the polar aprotic solvent, what is the role of polar aprotic solvent? Example of polar aprotic solvent, anyone? Polar aprotic solvent example. What is the role of the polar aprotic solvent? What is the role of polar aprotic solvent? Acetone. Good. Acetone and the rest other. Okay. Done. Here in the polar aprotic solvent, DMSO, polar aprotic solvent. In the polar aprotic solvent is a DMSO, right? Sorry, acetone, right? Now this is a acetone. This is a acetone. Okay. This is a which one? Acetone. No. Now this is a acetone. Now in this acetone, I was adding the NaCl. What it will happen now? We'll see. Na plus will be surrounded by the acetone. Na plus it will be surrounded by the acetone because oxygen it is having the partial negative charge. Done. Now in this manner the acetone will be surrounded with the Na plus, so that what it will happen, cation will be soluble in the polar protic solvent. Cations will be soluble. Cation is soluble. But when it comes to the Cl minus, now for this Cl minus, if you see, now if you see the which one, for the Cl minus, Cl minus. Here it should be attacked to the which one? It should be attacked to the carbon deficient. Where the carbon deficient it is there? Carbon deficiency is here. Then when the Cl minus want to form the bond between this one, here the CH3 bulky, here the CH3 bulky. Now here the oxygen, here we are having the lone pair of electrons in this manner, bulky and bulky. The Cl is not having a chance to form the bond with the which one? Acetone deficiency carbon. So that's the reason in the polar aprotic solvent cation is soluble, anion is insoluble. This is very key point you have to remember. So what is the key points you have to remember here? What is the key point? Key point. First one, polar protic solvent. Polar protic solvent, both cation and anion is soluble. Anion is soluble. Both cation and anion is soluble. In the polar aprotic solvent. Polar aprotic solvent. In the polar aprotic solvent, only cation is soluble, but not anion. This is the one very key point you have to remember, so that you will not have any, or you will not get any confusion when we are taking the which one when we are taking the, whether we are taking the polar protic solvent or polar aprotic solvent. Polar protic solvent or the polar aprotic solvent. Then now next one, aqueous KOH if they have given and alcoholic KOH if they have given. Here also many of the students, they will have the misconception among the aqueous KOH, among the alcoholic KOH. Alcoholic KOH means C2H5OH. This is alcoholic KOH. In the alcohol, if the KOH is present, that we call it as a alcoholic KOH, means a solvent. In this solvent will play very role. Here the aqueous means H2O. Aqueous means nothing but H2O. We know here the OH minus is a nucleophile, it will be act. In this OH minus, plenty of the H2O molecule will be surrounded to this one. Now here this OH minus is giving its electron pair donor. Electron pair donor to the which one? It is donating its electron pair donor to the H2O. Then if the OH minus, if it is donating its electron pair donor to the OH minus, what it will happen? Electron pair donor to the H plus if it is donate, then what it happen? It will acting as a base, right? It will acting as a base. Then what it will happen? Here the nucleophilicity, basic strength decreases and the nucleophilicity strength increases here for this one. Here the basic strength decreases and the nucleophilicity strength increases in the aqueous KOH. But when it comes to the which one? Alcoholic KOH, in this manner, this is alcohol and here if it is a OH minus, then what will happen? Here the basic strength increases, nucleophilicity site or nucleophilicity strength decreases. This is a one very key point you have to remember for whenever they have given the alcoholic KOH and the which one? Aqueous KOH. Aqueous KOH if they have given what? Basic strength decreases, nucleophilicity strength increases. Is it clear? Still you are having any confusion over there? Done? Clear, right? Any confusion you are having? If it is clear for you, now I will start the first one, SN1 reaction, unimolecular substitution reaction. First one, unimolecular substitution reaction. Unimolecular substitution reaction. Unimolecular substitution reaction, that is SN1. Clear? In this SN1, what are the in this SN1, what it will happen? Now we'll see. Here when I was taken the one alkali halide, now one 3 degree alkali halide with the chiral carbon containing with the different Clear? Now one 3-degree alkali halide was taken. Now in this 3-degree alkali halide, in the presence of, these are the some reagents we can use it in the, which one? In the SN1, aqueous Ag2O and aqueous KOH. Done? Clear? And the moist Ag2O. Done? Clear? Then these are the some, which one? Reagents that we are going to use. Aqueous, right? Aqueous is nothing but H2O. Now H2O, what it will happen? H2O, this chlorine being the more electronegative, it will form the bond with the H2O. It will form the bond with the H2O in this manner. When it is forming the bond with the H2O, what already I said, polar protic solvent will be solve the anion also. Then when this anion is surrounded with the H2O, due to that, what it will happening? When it is forming the bond, energy releases, right? That energy will be utilized by this bond, and this bond will be as a what? This chlorine, as it will take this bond pair of electron and it will leave. What? When this H2O, when it is forming the bond with the chlorine, due to that, what it is happening? Due to that, bond energy is releasing, or energy is releasing. Due to that, when the energy has released, what it will happen? It will take this bond pair of electron and the what? X will be leaved. Halogens are the good leaving groups, we know. Then after that, here what it will form? Here it will form the one carbocation, it will form. One carbocation it will form. Done? When it has formed the carbocation, now this carbocation is a sp2. We know sp2 is a planar. When it is a sp2 is a planar, then what it will happen? If the sp2 is planar, then we can attack the nucleophile from the above end. We can attack the nucleophile from the above end, or we can attack the nucleophile from the below end. If wherever the nucleophile it has gone, from there if attacking, if it is happened, or nucleophile if it is attacked, then this one we say it as a retention product. Same side from where the nucleophile has gone and the OH minus added, that we call it as a retention product. Next one, where the which one? Where the leaving group has eliminated and the OH minus is added, this one we call it as a inversion product. This one we call it as a inversion product. Now retention and the inversion, we call it as what we call? Retention and the 50% retention and the 50% inversion. What we call, Amma? Can anyone? 50% retention and the 50% inversion. What we call? What we call 50% retention and the 50% inversion? We call it as a racemic mixture. And this one we call it as a which one? 50% retention and the 50% inversion. We call it as racemic mixture. This two we call it as a racemic mixture. This two we call it as a racemic mixture. Done? Clear? Now, here what are the key points you have to remember for the, what are the key points that we have to remember for the SN1? SN1 key points. First one is a 3-degree alkali, halides and alcohols. 3-degree alkali halides and the alcohols readily undergoes SN1. Readily undergoes. We can say it as a readily undergoes. Readily it will undergoes. Readily undergoes SN1. Readily undergoes SN1. Done? Next. Here this is concerted reaction or the non-concerted? This is non-concerted reaction. This is non-concerted reaction. Non-concerted means intermediate present. Intermediate present. If any intermediate is present, that we call it as a non-concerted reaction. What is the intermediate here? Carbocation and rearrangement takes place. Carbocation and the rearrangement takes place. Carbocation will form and the rearrangement will be takes place. Then, now, next very key point you have to remember, SN1 reaction. Okay, I will write it in the fresh page so that it will be very clear for you. Now, SN1 reaction is the SN1 reaction. Space Prince, where you did not understand? Where you have did not understand? Where you have not understand? No, Prince, I was not ignoring you. Where? I was asking where you have not understand. My question is where you have not understand. I was asking that only. Where you have not understand. Where you have not understand. Where you have not understand. My dear Prince, I am asking where you are not able to understand. I mean, in which concept? In which concept? Sir, you continue after 5 minutes, I will tell. Okay, fine. Done. Now, here, okay, fine. Done. Next. Here, the carbocation, the first very key point you have to be remember here, SN1 will depend upon the nucleophile or it will depend upon the stability of the carbocation. Now, here the SN1, the one who are in the online, they can, one who are in the live, they can say me the answer. Now, the SN1 reaction will be depend upon the stability of the carbocation or depending upon the incoming nucleophile. It will be depend upon the alkali halide which provides the stability of the which one carbocation. So SN1 reaction, so its rate of reaction depends on formation of stability, formation of stable carbocation. It will depend upon the stable carbocation, not on incoming nucleophile, because the alkali halide which produce the stable carbocation, on that alkali halide SN1 reaction will be produced, but not on the basis of whatever the carbocation you have taken. It will not depend. Done. Here, now what are the, here you can see graph. If you take the graph, now this is a concerted or non-concerted, this is a non-concerted reaction. Now potential energy, now if you take this as a one alkali halide, now alkali halide when it is reached to the transition state, now very fastly it will form the stability of the carbocation. Now this is a rate determining step. Clear? Now the formation of the carbocation is a rate determining step. Then after the formation of the carbocation, now very fastly the product will be formed. Now to understand this one very clearly, what is the meaning of the rate determining step and after the formation of the rate determining step, here see, listen carefully. Here I will take one jar, Nana. Here I will take one jar. Okay, now in this jar, after that again we are having the another jar. Here we are having the another jar. Clear? Now here I was taken, let assume here it is having a some transparent or not transparent, it is having some mesh. It is having some mesh type, let assume mesh means some holes type we are having. Now when I was poured a sand here, when I was throwed a sand here, indulo some సన్న ఇసుక వేసినప్పుడు వాట్ ఇట్ విల్ హ్యాపెన్ వెరీ ఫాస్ట్లీ here the what it will happen here that sand will be what sand will be here, right? From that sand some part of the sand will come. అది ఎప్పుడైతే మెష్ లో నుంచి వచ్చిందో వెరీ ఫాస్ట్లీ ఇట్ విల్ కమ్ డౌన్. ఇక్కడ మెష్ లో ఉంది నా మెష్ మీద ఇక్కడ శాండ్ వేసిన, నేను ఇక్కడ శాండ్ వేసిన. ఈ శాండ్ మెష్ లో నుంచి వచ్చినప్పుడు డౌన్వర్డ్స్ వెరీ ఫాస్ట్లీ వస్తుందా లేకపోతే వెరీ స్లోలీగా వస్తుందా? Can anyone say me? ఇప్పుడు నేను మెష్ మీద శాండ్ వేసిన, ఈ మెష్లో నుంచి ఒక్కసారి శాండ్ కిందికి వచ్చినప్పుడు అది వెరీ ఫాస్ట్లీగా వస్తుందా? ఫాస్ట్లీగా వస్తుంది కదా. ఇన్ ద సేమ్ వే ఇక్కడ కూడా రియాక్షన్ అప్ టు ద ట్రాన్సిషన్ స్టేట్ ఆర్ అంటిల్ ఇట్ ఫార్మ్ ద స్టేబుల్ కార్బోకేటయాన్, అంటిల్ ఇట్స్ ట్రాన్సిషన్ స్టేట్ ఇట్ విల్ బికమ్ స్లో, until it will become, that we call it as a rate determining step. Slow step we call it as a rate determining step. Once the stable intermediate it has formed, very fastly in the fraction of seconds or very fastly the product will be formed. ఇక్కడ కూడా మనం ఇక్కడ రియాక్షన్ వేసినప్పుడు అది సెర్చ్ చేసుకుంది ఏది ఎక్కడ మెష్కి హోల్ ఉంది ఆర్ ఎక్కడ మెష్లో నుంచి నేను బయటికి వెళ్ళగలుగుతా, అప్పటి వరకు స్లోగా ఉంది. ఒక్కసారి ఆ మెష్లో నుంచి బయటికి రాగానే వెరీ ఫాస్ట్లీగా వచ్చింది కదా, అంతే. ఇది కూడా అంతే. ఆల్కలీ అలైడ్ ఫస్ట్ ఇట్ హాస్ సర్చ్డ్ ఫర్ ద స్టెబిలిటీ ఆఫ్ ద కార్బోకేటయాన్, దాన్ని రేట్ డిటర్మైనింగ్ స్టెప్, స్లో స్టెప్. అది ఒక్కసారి ఇంటర్మీడియట్ ఫామ్ కాగానే ఏమైంది, వన్స్ ద ఇంటర్మీడియట్ హాస్ ఫార్మ్డ్ వెరీ ఫాస్ట్లీ ద ప్రోడక్ట్ హాస్ బీన్ ఫార్మ్డ్. క్లియర్? నౌ దిస్ ఈస్ అబౌట్ దిస్ ఈస్ రియాక్షన్ ప్రోగ్రెస్. దిస్ ఈస్ a what energy profile diagram for the SN1. Now graphs we'll see. Graphs. This is a rate of the reaction and this is a incoming nucleophile. Clear? Now this is a rate of the reaction and this is a substrate. Now here in the first graph how the graph you will get, in the second graph how the graph you will get, and what is the order, and what is the order. Now rate is directly proportional to, rate of the reaction is directly proportional to the what, independent of the nucleophile, so constant, so it will not depend upon the incoming nucleophile, so it is constant. Second graph space prints, you are having prints, are you there? Prints, are you there? Are you in the live? Now second graph how you will get, y is equal to mx plus c. Y is equal to mx plus c ఎందుకు వస్తుంది అన్న? Y is equal to mx plus c కాదు, k is constant. Y is equal to mx, this is y is equal to mx, because rate will be depend upon the which one will provide the stable, y is equal to mx, the which one will provide the stable substrate, right? So this is y is equal to mx. Now the rate will be equal to the substrate and its order is 1. Its order is 1. That's the reason we used to say this is unimolecular substitution reaction and its order is 1. Order is 1 in the polar protic solvent. Next one is a okay, fine. Next type we are going to see the ion pair mechanism. This is very important. Sometimes in the statement based question also they may ask ion pair mechanism of SN1. Now what is the meaning of the ion pair mechanism? Here you see, if you take the alkali halide, in the presence of polar protic solvent, this is H2O. Polar protic solvent is a H2O. When the polar protic solvent if they have taken, now the plenty of the H2O molecules will be surrounded to this one. When the plenty of H2O molecules are surrounded, at the time of bond breaking, and the bond, when the bond breaking time, here it will get the negative, and at the time, now here which product will be formed? What they will ask you, in the polar protic, in the SN1 reaction, among the inversion product and among the retention product, which product will be formed first, they will ask. which product will be formed first? When the polar protic solvent, when we have taken, now when the carbocation has been formed, if this nucleophile, if it is coming from this end, if the nucleophile, if it is coming from the same end where the leaving group is going, this nucleophile is having the electrons and this halogen is also having the electrons. Electrons will get repelled. Due to that, first what it will happen, in the SN1 reaction, first inversion product will be formed. First which product will be formed? Inversion product will be formed. First inversion product will form, then after that retention product will form. Inversion product is greater than the retention product. Inversion product is greater than the which one? Retention product. So you have to be very careful. In the statement based question they are asking. In the statement based question they may ask, in the SN1 reaction, in the ion pair mechanism, which product will form very fast? Okay, inversion product will form, because when the carbocation has formed, where the leaving group, if it has eliminated, from there the nucleophile, if it is added, then it will get repulsion. So that's the reason first nucleophile will be added in the inversion, then after the retention. Clear? Because SN1 reaction is racemic product, right? SN1 reaction is racemic product. This is also one very important. Clear? Now next, here I will write the some questions. Now you have to say me. This is very important. Now listen carefully. First one, here the CH3 CBr. Okay, not like this. Okay, this is one. Done. Next, second one. This is a second one. Now third one. This is a third one. Now among the 1, 2, 3, in which case SN1 reaction happens fast. SN1 reactions happens fast. In which case SN1 reactions happen fast. Order: SN1 reactions happen fast. In which case the SN1 reaction happen fast. In which case the SN1 reaction happen fast. Chapana, in which case SN1 reaction happen fast? Anyone in the live? Try to give the answer. If not we will move to the next question, or if not I will say. Anyone in the live? 2, 3, 1. 2, 3, 1. Lower to higher, higher to lower. You have said. You have said in the form of lower to higher or higher to lower. Pranit, the answer you are given is in the form of lower to higher or higher to lower. Two, 3, 1 is of lower to higher or higher to lower. Higher, sir. Higher is 2 you are saying. Higher is 2 you are saying. See, what is the intermediate that it is present in the SN1 reaction? Can anyone say me what is the intermediate that present in the SN1? Carbocation, right? Allyl carbocation. No, here this is very important. Sir, bromine repeat. Roast toast. What is the bromine repeat? Here you can see. Here, if this bromine, if it is eliminated in the SN1 reaction, in the SN1 polar protic solvent, if the bromine, if it is eliminated, now here you will get the 3-degree carbocation. Then after that you will get here the allyl carbocation. Then here you will get the phenyl carbocation. Sir, benzyl carbocation. This is a benzyl carbocation. among the 3-degree carbocation, among the allyl carbocation, among the benzyl carbocation. Now you say me, which is a more stable carbocation? Which is a more stable carbocation? Which is a more stable carbon? Topic repeat. Which topic I have to repeat? My dear roast and toast. Now let me complete this. Okay, fine. Now, which one is a more stable carbocation among the 1, 2, 3? Among the 1, among the 2, among the 3, which is a more stable carbocation? 3. No, the order is 1 greater than 3 greater than 2. SN1 reaction will be happen fast in the 1, then after 3, then after 2. This is the order. Do you know the reason? Can anyone know the reason? Can anyone know the reason why this is happening in the 1, 3, 2? Why it is happening in the 1, 3, 2? Mesomeric effect not there in benzene, sir. Mesomeric effect is not there in the Praneeth, you are doing mistake. Somewhere you are making the mistake. Now listen. I will explain. Now listen. Here in the 3-degree carbocation, this is a 3-degree carbocation. Okay, this is a 3-degree carbocation. Now when it comes to the benzyl carbocation, this is a benzyl carbocation. Done. Next one we are having the allyl carbocation. Done. Here we are having the 9 alpha hydrogens. This is a 9 alpha hydrogens. Here we are having the here we are having only 6 pi electrons. For the benzyl carbocation we are having only the 6 pi electrons. Done. Then here this carbocation is stabilizing by only 2 pi electrons. Here the 2 pi electrons are stabilizing this carbocation. Here the 6 pi electrons are stabilizing this carbocation. But here the 9 alpha hydrogens are stabilizing, right? 9 alpha hydrogens are stabilizing, right? So when the 9 alpha hydrogens are stabilizing, then the 6 pi electrons, 9 alpha hydrogens are more stable. So the order will be in this manner. You have to be very careful, and this is a very, very important, and this is repeatedly they are asking. Is it clear? So compared to the benzyl carbocation, which one? 3-degree carbocation is more stable. But if the benzyl carbocation and the 2-degree carbocation, if they are given, then the benzyl carbocation is more stable than the 2-degree carbocation. Is it clear? Is it clear, Praneeth? Still you are having any confusion? Clear, done. Now next suppose if I was given this one, now among the 1 and 2, which one will be happen SN1 reaction very fastly? In which case SN1 reaction will happen very fastly? In the 1 and 2. In the 1 and 2, SN1 reaction happen very fastly in the among the 1 and 2. In which case SN1 reaction will happen 1. Why? Reason why only 1? Why only in the 1? Reason. So that what will happen? 6 pi electrons are there. So that what it will happen? Due to that 6 pi electrons, what it will happen? Due to that 6 pi electrons, what it will happen? Here, if this bromine, if it is eliminated, this compound will become aromatic, right? Clear? This one is more stable than the second one. Compound will become aromatic. That's what you have to say. Now in the second one, among the 1, 2, 3, which is a more between 2 degrees. Now next